Hello, protocols, packets, and programs. I quite enjoyed Furiosa, the latest entry in the world of Mad Max. It's a dystopian future of scarce resources, outrageous vehicles, and more outrageous characters. It also makes it sound like Go and Rust are thematically perfect for a future that desires to be shiny and chrome. So even if things turn out mediocre, at least they'll be memory safe. Which means this week we chat with Aaron Parecki about OAuth 2, how specs influence security, and the nuances of authorization and authentication. Start your rig and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly.
On the Security Weekly news, I try to scan and produce a quick look at some of the major stories to help you keep up with what's going on in and around the industry in a short format. Myself, Aaron Leyland, Josh Marpet, and other guest commentators provide greater insight every week. I'm Doug White, and I hope that you'll look for the Security Weekly news in all of your favorite podcast catchers and subscribe for the latest content.
This is episode 289, recorded June 24th, 2024. I'm your host, Mike Shima. I'm here with John Kinsella. Hello, John.
Good morning. I'm glad we both saw the same movie and that we didn't see it at the same time, surprisingly.
But it was such a fun movie.
Great flick. Yeah.
That's right. So we're going to get to the green place by the end of this interview with Aaron. But first, our listeners need to know that we're always looking for great guests for all of the Security Weekly shows. Submit your suggestions by visiting securityweekly.com/guests. Aaron Parecki is the Director of Identity Standards at Okta with over 15 years of experience in the industry. He is active in multiple standards development organizations, including IETF, OpenID Foundation, and W3C. He's the editor of OAuth 2.1, along with several other OAuth specifications, and co-chairs the SCIM working group at IETF. He has taught the fundamentals of OAuth and security through his book OAuth 2.0 Simplified, as well as through video courses and live online training. Hello, Aaron. Thank you for joining us.
Happy to be here. Thanks for having me.
We're happy to have you here, and we will witness you as you walk us through those nuances of authorization and authentication. You're going to have to help me because I often pull in things like OIDC into OAuth. But before we start throwing around all of these acronyms, etc., I would love to hear a little bit about your background in the world of specs, and maybe, that's possibly a very large question, but you're working on some best practices around OAuth. Tell us a little bit about how you came to be working on that aspect of this particular type of spec.
Yeah, I mean, it really started back when I was working on building out an API myself, developer platform, and I knew that we needed some sort of API security solution, and OAuth seemed to be the way the industry was going at the time. This was around 2010, so you have to kind of rewind a bit in time to imagine where we were back then. I knew OAuth was the right solution for the job. I didn't know anything about it at the time. And I decided, well, I guess I have to learn it because this is clearly going to be what people are using in the future. So I just sat down one day and read through the entire spec, and I was like, you know what? Actually, that wasn't as bad as I thought it was going to be. And something clicked, and I was like, okay, well, why don't I write a blog post explaining what I just learned for myself mostly? And I summarized it, the spec, and that blog post is still the most popular post on my blog to this day, which is maybe a little telling of other things, but it's okay. But yeah, that's really how I got started with it. And since that point, I just have continued to be involved in, I started asking questions on the OAuth mailing list about clarifying aspects of the spec as I was going, and just kind of found myself contributing to discussions, answering other people's questions on the list and off the list, and just kind of grew into becoming part of the community, really.
That's all. And I love that this was driven a lot by curiosity, followed by sharing what you learned with everyone. That's a theme that we love to emphasize on the show. Before we get into maybe the modern aspects of OAuth and where the spec is now and going, what made it stand out to you as I think, as you said, kind of the right way to do it? Because I think you have alternatives of ancient things like HTTP basic auth, which I don't think really, thankfully, picked up. But, digest auth, just a shared secret. There were alternatives, but you picked a pretty good one. But
no, definitely there were a lot of different ways to approach the problem at the time, and I think what made it come together for me was really the emphasis which was a design goal of OAuth 2 in particular, of developer simplicity, and this was really a intentional design goal that the community was going towards, which was directly in contrast to OAuth 1. OAuth 1 had a really obtuse signature algorithm that you had to implement when you were actually writing your own code to make OAuth requests. And everybody would get it wrong all the time. It would just be the source of a bunch of errors. And that was dropped in OAuth 2 in favor of an access token. And the idea of an access token is that once you do the OAuth back and forth dance, you get the access token, and then that's what you use to make API requests. And that kind of moves the complexity to the acquisition of the token, and then things are back in sort of normal, easy to use developer land from there. So I think that really made sense to me as a design goal of let's try to keep the application level code simple and easy to use for developers, and move the complexity to the acquiring of that token.
And that's got to be a measure of success, that if there's an investment in actually making it usable for developers in a way that they're not going to always make mistakes. This may be a truism, or that we have the benefit of hindsight, but part of its success, I think, has to be at least pointed to that developers can use it. But I think you've been obviously watching this for over a decade. The specs have also changed, not just to make things better for developers, but has also reacted to new threats, new attacks. So so tell us a little bit about what are emerging threats, or how the threat model has been updated from OAuth 1 to today.
Yeah, so I mentioned that one of the design goals was developer simplicity, and that did come at the cost of security. This is a common trade-off of, do you want it to be easy to use or do you want it to be secure? And then not to even mention throwing in the user experience into that equation. But at this level of the protocol, the user experience isn't really a consideration because it's all just behind-the-scenes stuff. But the trade-off between developer simplicity and security is very real, and that was, while it was a good goal, and I think it was the right decision at the time, and it kind of got things going in that direction, it is not enough right now. And the problem is, one of the biggest problems we have in the industry right now is just the idea of bearer tokens. So an access token that you get through an OAuth dance, or even just an API key, is ultimately a bearer token, meaning if you have that token, that is all that you need in order to use it. You got a string at some point, you take that string, you put it in a header, and you make an API request, right? So it's the same thing that you got that you're using for the request, which means if somebody else can steal it, they can also use the token, and it looks exactly the same as the real client using the token. And this is a real problem, and it shows up in OAuth, but also just in browsers. Cookies have the same problem. Cookies are ultimately bearer tokens. The cookie might be a encrypted cookie or a signed cookie or even just an opaque identifier, but it doesn't really matter because that cookie is the thing that gets sent to the server, and it's a shared secret between the client and the server. So if somebody can steal a cookie, they look like the real client. So this has been the source of many, many problems over the years, and very public vulnerabilities and hacks and account takeovers. And this is really something that we're now trying to solve in both the OAuth community as well as in the browser community.
Yeah, and I think, to jump ahead a little bit, this is where it's Depop, right? And I'll let you explain what Depop is in a moment. But we've also got, if you can add too, Microsoft has Bpop, just to be a little bit different. And what Chrome has their own approach to this in the terms of protecting the user cookies, as you were saying. So tell us a little bit about this. And then with the idea that we now have a couple different specs competing with each other, working together? What does this imply for something like OAuth?
Yeah, for sure. So ultimately, the problem is a shared secret, a bearer token. So in order to solve that, we need to what we in the industry call sender constrain the token. Constrain the token so that it's only usable by the intended recipient of the token. And that concept is pretty much universally agreed upon in all these different specs. The concept of you issue the token to a piece of software, and that piece of software should have some way to prove when it uses a token that it is the same piece of software that got the token. So nobody disagrees with that premise, but then how you actually accomplish that can be expressed in many different ways. So in the OAuth world, we actually have had mutual TLS for quite a long time. And mutual TLS is the idea of using a client certificate in your HTTP connection to prove that the thing making the HTTP request is the same thing that has shown up before using the same certificate. That turns out has many challenges when you actually go to deploy it, because you might have things like TLS terminators somewhere along the way, and then you have to deal with all that stuff, plus scaling that up and managing key rotations. It's a challenge. People have deployed it for sure in some scenarios, but in many cases it's too complicated depending on how the rest of your stack. So an alternative to that is Depop, like you mentioned. Depop is, the acronym is silly. It's demonstration of proof of possession. Proof of possession and is again the name for this concept we're trying to do, which is prove that the possessor of the token is the same when it goes to get used. That works fundamentally differently than mutual TLS. Depop works in the application layer, which means your application level code creates the signature and then puts a header in the request next to your token, and then you send both things. And what this means is that because it's in the application layer, your TLS stack is completely unaware of this happening. So you can go through proxies and forward the request to other backends and all that kind of stuff, and you don't need to worry about your infrastructure when you're going to deploy it. It also, interestingly, works in browsers, which is was a big motivator for the design of it. Because mutual TLS doesn't really work in browsers because you can't get your browser HTTP client to give it a client certificate, but you can create a Depop signature in JavaScript. And if you actually use the Web Crypto API to create a non-exportable key in JavaScript, then you can actually get a pretty good solution for sender constrained tokens in browsers. Again, at the application layer, meaning you have to actually write JavaScript code to do this signature generation. So that's the OAuth side. Now, you also mentioned the browser side. Bpop and Google's DBSC, I believe is the acronym. That is addressing the same problem, but for cookies rather than OAuth tokens. And the premise there is that signature, that proof of using the key would be handled entirely by the browser, not by JavaScript code, not by user space JavaScript. It would actually be done by the browser itself. So the browser would have some key that it uses, and it would, when it goes to send a cookie, also include some sort of signed thing in the request proving that it's the same browser that was issued that cookie. So there's Google and Microsoft's versions. Microsoft's is called Bpop, browser proof of possession, and it is actually modeled off of Depop from OAuth. It doesn't work exactly the same, but it's modeled after it, and it's very similar. Google's it takes a different approach, but solving the same problem with the same concept of asymmetric cryptography.
And ultimately, the idea that there's a secret that lives in an enclave that can't be exported to be replayed, which is going after that particular threat model. But what's interesting, as we're listening to you, there's a bunch of different specs here, and it seems to me no one just does OAuth, for example, and nor is OAuth a monolithic spec, right? Mm-hmm. So tell us a little bit about what does it mean, if we're a small startup, engineering constrained, we want to employ, you want to use OAuth. How many dozens, plural, of the specs do we need to pay attention to?
Well, yeah. So there's a lot of different specs under the OAuth umbrella. It starts with the OAuth core spec, then there's the bearer token spec. There's Pixie was added later. There's the security best current practice. which is almost an RFC at this point. And I would say you don't necessarily need to read all the specs, but if you're actually implementing this stuff from scratch as opposed to using like off-the-shelf tools or libraries or services, then you would at least need to read the security best current practice and things that it points to, because that's the most up-to-date that we have right now. Now, OAuth 2.1 is a consolidation of the security best current practice with the preceding specs. So we're trying to sort of make a new baseline where you can start with OAuth 2.1 and go from there. But it's not finished yet, still in progress. So in the meantime, the security best current practice is the most up-to-date version of that. But all that said, the far best way to handle this is to not write all this code from scratch and go use, at the very least, a library to handle this stuff for you. And even better would be to use an open source full authorization server stack or a service, a product that you are subscribing to that provides the authorization server, which already handles all of these specs. So, and then you just sort of interface it through its API docs, which would be the best version of doing OAuth.
As you mentioned that, for example, there is the idea of there's a best practice document where you have to read through and say, conceivably as a developer, I need to make sure I'm just making good default choices, I'm implementing this correctly. Sounds like 2.1 is much better about just do this in a way. But even with using these libraries, how much of them do you feel that in the open source world are giving good security defaults? Excuse me. Basically good starts, good beginning versus to how this should be done versus still putting a lot of the burden on developers to figure out, well, is the trade-off here security, usability? Is the trade-off, was this disabled by default just because the spec said so at one point? What are some insights there you could share?
Yeah, it is tricky. So this is, again, OAuth 2.1 and the security best current practice are meant to be the sort of common baseline level of security. So following that should be a default, and there should be no reason to not do the things that are required by those. That said, there are still going to be more things that you'll find pointed to by both of those documents that are additional security features that maybe you don't actually need depending on your scenario. And that might be things like sender constrained tokens. Not everybody actually needs that, and there are trade-offs. It is more complicated to deploy. You have to deal with key rotation, but it is a good recommendation. It's a strong recommendation to do it, but in some cases, people don't care about that particular problem. Another one might be how much you care about client authenticity, as in, do you care about somebody being able to impersonate your mobile apps? Because mobile apps can't be deployed with shared secrets or secrets because they would be shared. Right. And that means you don't really ever know if the mobile app is making a request to your authorization server or if it's somebody pretending to be the mobile app. Do you care about that? Not everybody actually does. In some cases, that problem doesn't matter. And in some cases, it matters a lot. And if it matters to you a lot, then you will have to go do other things to solve that problem.
So yeah, and as an example, if you're doing like e-commerce, I'm sure is much more sensitive to the authenticity of the client because they're using a credit card, and you don't want to have an attacker who's just trying to replay and guess a whole bunch of different credit cards to your endpoint. You just want that one person who's making a legitimate purchase. With that, you're describing the mobile app. You're describing a little bit earlier about the browser focus, like these device-bound sessions from Chrome, Microsoft's B for browser depop or browser pop. How much of this? And there's also things like Safari, for example, is moving to, and others moving to restrict third-party cookies. There's a lot of privacy aspects of this. So in this world of privacy constraints and browsers or mobile app developers doing what they want, I'll say kind of hand-wavy, how does it impact spec designs or the future of something like OAuth?
Yeah, there's a lot of discussions going on right now that cross over between OAuth, browsers, privacy, and now even wallets. And they're all kind of tied together because the concept of wallets and verifiable credentials is the idea of privacy preserving issuing of information. So I should be able to, for example, rather than sign in with Facebook or sign in with Google, where when I'm going to a website and I use click that button, Google knows that I signed in there, and Google gives them sort of like a default set of profile attributes about me. Usually it's minimal, like name, photo, and email, but I don't get to choose name, photo, or email. That's just what's sent. And I didn't get to choose that, right? And if I go use sign in with Facebook, they might give name, photo, email, and something else that I didn't really choose, right? So there's a shift towards the verifiable credentials and wallet concept where I would be issued credentials from a provider like Google or Facebook, but then I would choose which attributes to share with the site I'm logging into. And importantly, the issuer doesn't know that I'm using them when I share them with the site I'm logging into. So that's an aspect of trying to add back privacy, but we'll see how that actually ends up playing out in practice, because that's sometimes at odds with goals of other players in the ecosystem, right?
And now you're bringing in this identity aspect. And I was trying to also myself be careful not just to say OIDC is equal to OAuth.
Yeah.
You actually helped me avoid that mistake. And here I'm going to throw out like FedCM is another acronym. So let's talk about maybe that, or bring the identity in general into this. And how does this, why is this related to OAuth? And what are the dangers of conflating the two?
So if you rewind back to when OAuth was originally created, the goal of OAuth was to limit the access that you're granting applications, limit the API access. So it was very common at the time to have not just sign in with Twitter, but actually connecting an app to post to your Twitter account, right? Using a third-party client to read and create data in your account. So for that kind of thing, like you want to, the photo printing example is always used in the early OAuth days of I have all my photos in Flickr and I want to go log into this kiosk at the store, grant access to my Flickr account, but I don't want the kiosk to get infinite access and be able to also upload photos and download all the private photos. I just want to authorize access to, just my public photos. So you have to rewind to thinking about that problem of limiting the access that you're granting a third-party application. And for that's what the access token does, is it represents the fact that the user has agreed to authorize limited access to an account. And that limited access is encapsulated in the access token. Now, that is very, very different than signing into an application, although it's obviously very related as well. So back to what I just said about when we use sign in with Google, Google shares profile information with the app, right? And that's how the app knows who signed in. Well, you can think of that as granting access to data, to my profile data. And that's why OpenID Connect builds on top of OAuth but OpenID Connect is adding the concept of there is profile data and you can get access to it. Whereas OAuth just talks about APIs, just API. It's just protecting an API. It doesn't really care about what's in it. It could be user information. It could be users' photos. It could be whatever, right? But OpenID Connect says there is profile data. Here is how you can request it. Here is how it is represented in the spec. And that's for the purpose of signing into applications.
Gotcha. And that's helpful to understand that distinction between here is just sort of a, what permissions read, write, access to the API versus can you give me generalized information or established information about this user or this object, if you will. Another aspect of that then is how does something like WebAuthn, I love what WebAuthn, so I want to bring it up, but what does that have? Does that also have implications for OAuth in this sense of, sign in with Apple, sign in with Google, and is that changing OAuth in any way or narrowing the use cases where OAuth might be, is it going to go back to just that API access grants?
Yeah, WebAuthn and passkeys is a great development because it essentially means that we don't need passwords for the first party case. But the implications for that sort of third party federated login are also really, really interesting. So a lot of sites, they will give you the option of signing in with Google. Sometimes it's for the user experience benefit of not having to type all your information again, but also because it's just a quick way to have a stable identifier to that user, to that actual person, right? So I do suspect that what we will see in the future is a combination of the two, where the downside of like only passkey login is that there's absolutely no profile or user identifying information in it at all, right? It's just the credential. It's just the credential, which is exactly what it was created to do. It's not meant to replace all those. So I suspect we'll actually see the two used in conjunction, of a federated login when the user creates an account, and that's a shortcut to providing the name and the photo and the email, and it's also then verified by whoever that provider is as well. And then enroll a passkey immediately after that, where you can use the passkey to come back and log in the future, because that actually gets you a better user experience. It's a better user experience to log in with the passkey versus logging in through federated login every single time, right?
Yeah, and I guess, and part of it to add, that I see is an echo of the passkeys have that not only device-bound aspect, but they're cryptographically bound to the domain that you're speaking to, which is another way to minimize the impact of phishing, intermediation attacks, or replay attacks. But we're talking about OAuth, so I'll bring us back around, and let's turn our view a little bit to the future and go back to that OAuth 2.1. I'd love to hear some more about what does it mean, or what are the challenges in updating a spec like this? Like, what goes through your mind in that broad balance of security, developer experience, and user experience to figure out, well, this is the default, quote unquote, best, most secure way to do this, and everything is fixed?
Yeah, it's definitely a challenge. There's also factoring in the deployment challenges of upgrading to the spec, which is another factor that you don't necessarily have to deal with when you're just starting from scratch. So we are updating OAuth to OAuth 2.1 with the intent of not having to have people rewrite all of their code, assuming that they're already following the best practices, which is the assumption there. So if you hadn't been following along over the last 10 years of the development of OAuth, then you might need to do make some changes and implement a couple of extensions and remove some options and lock a few things down here and there. If you have been following along the whole time, then you should already be OAuth 2.1 compliant, right? So that's definitely a design goal of the update. We did not go into it trying to reinvent how OAuth works. That was not the goal. But yeah, the other trade-offs here are, again, developer usability and security. But what we were trying to do with OAuth 2.1 in particular is actually not change anything compared to what's already written in this handful of specs, like the security best current practice. So if you've been following along and if you have been updating, then theoretically no changes are needed to be considered OAuth 2.1.
So is there going to be some sort of a tool or site or library for people to be able, like a developer, to be able to go and test to see, does that compatibility actually work for them, or do they have to test and prod?
Yeah, no, that's a good question. This actually gets to another aspect of OAuth that is confusing, somewhat controversial, which is the how interoperable is it actually? And OAuth 2.0, especially if you just look at RFC 6749, which is it actually is called a framework, not a spec, and that was a last-minute name change when it was published, because it is not interoperable. Like, if somebody implements that spec, it is not guaranteed to interoperate with somebody else who has only looked at that spec. Essentially, there are decisions you have to make in order to make it interoperable. One of which is, how do you want access tokens to work? That's 6750. So, did you implement that also? Okay, now at least we agree on the concept of bearer tokens. But it kind of goes from there, right? And this is, I think it was the right decision to have that be the way it was published at the time, so that we could kind of move on and move forward. But in 2010 or in 2012, when OAuth was published, it was not published as an interoperable spec. So fast forward to now, is there going to be a test suite? Well, the IETF doesn't really have the infrastructure to develop those kinds of tools. So the OAuth working group is not going to develop a test suite. It isn't possible. Somebody else could definitely come along and develop one. One example of that is the OpenID Foundation. So OpenID Connect, we've been talking a little bit about OpenID. One thing we haven't talked about yet is the OpenID profile of OAuth called FAPI. So FAPI, long story on the name, terrible name. Now it doesn't actually stand for anything, so it's just the letters, FAPI. But the premise of that is it is the high security and interoperable profile of OAuth. So it takes OAuth plus the security best current practice, so OAuth 2.1, and it locks down a whole bunch more stuff. It says things like one of the only choices you have to make there is whether you want to do your sender constrained tokens with Depop or MTLS. And that was just because there were some deployment scenarios where people wanted to use MTLS and not do Depop. But other than that, there's like so many of the optionality things are locked down. And that is the interoperable profile of OAuth. And because it's in the OpenID Foundation, which does have an actual certification tool, there is a test suite that you can use to test against that. So while there's no test suite or interoperable test for OAuth 2.1, you could go all the way to FAPI and use the most secure version of OAuth and get a conformance test tool in order to actually test your implementation that way.
Okay, I want to take a step back. So zoom way back out, and we've been in the weeds, and you've answered this question in a lot of detail. But maybe we should have asked this at the beginning, but here we are. At a really high level, why is this so damn complex? So we've been doing this type of stuff for OAuth has been around for 15 years, I think, somewhere around there. I'm guessing. But why? I mean, I understand there's always a reason to improve and come up with new things, but for the development community out there, it's which one of these do I pick? Or why is this not just there's my auth or there's my ID? Excuse me.
Yeah, that's a good question. So at a high level, I guess going back to what I originally said about the design goal of OAuth 2 was developer simplicity. That was a very, very important principle, which comes at the expense of security. So now we have people doing OAuth 2, maybe not as secure as an implementation should be. So the attackers come along and find ways to attack systems, taking advantage of the security holes that were not solved by that spec. So then we add more specs, we add more security, and then the attackers find a new thing, and then we add more security and more specs to solve those. And that's kind of what led to where we are with FAPI today, which is, okay, there's a whole bunch of stuff locked down. There's a whole bunch of security checks in a bunch of different places that mean attackers are going to have to move on to something else. But they will. They will move on and find a new way to attack, which might look totally different than what we've seen today. Like stolen cookies and stolen tokens are a very common attack. Once that is not possible anymore, well, what are attackers going to do? They're going to maybe switch to phishing attacks and trick the user into just granting access to the data rather than access to the API and try to steal data from users. That's just one example. There's going to be a whole bunch more things like that. And I think this is why it's complicated, because you have to make a choice at some point about how do you want this system to work, especially if you want to be interoperable. You have to get everybody to agree on that. So you have to make a choice about how secure do you want this to be, with the goal of it also being interoperable in order to actually ship code at some point. And then that means you've probably compromised somewhere. And that compromise is going to come back, and you're going to have to solve that problem later. So this is why it's complicated, because it's just an ever-changing space, and there's always going to be people trying to take advantage of a system, and they're going to find a way, and then you're going to have to solve that problem.
Is part of that, and maybe this might be a little tougher to answer, but you described going from a 2.0 to a 2.1, and 2.1 trying to be a bit smarter about the defaults. Here's some maybe rebalancing some of those security trade-offs, I think is fair way to what you were describing. What would it take to be a 3.0 version of this? And how many decades in the future should we come back to talk to you about that?
I mean, that's a can of worms right there. But I think that I don't think that there's a version of OAuth that is going to be 3.0 that looks anything like OAuth. And I think that at the time that there's going to be something that might solve a similar problem as OAuth, it's going to look so different that you wouldn't even necessarily call it that anymore. One example of this is FedCM. You mentioned this at the beginning, and I kind of forgot to actually describe and go into that, which is this is an example of the browser inserting itself into the whole flow, which is very different from how OAuth has traditionally worked, which is the browser has sort of always been this entity that you kind of have to work around. And now the browser is going to be putting itself in the middle of the flow. And that changes a lot of things. A lot of assumptions change, and a lot of there's different privacy implications there as well. And I think that that's an example of how this industry is changing in a way that maybe wasn't expected as a natural evolution of OAuth 2 to OAuth 3, right?
Gotcha. Yes. So, yeah, I guess we'll have to have you back before another couple of decades, a little bit earlier than that, to figure out whatever iteration or version this will be, or at least whenever the next Mad Max movie comes out, so we can chat about that in more detail. But Aaron, before we let you leave, we've been asking all of our guests to help us fill in the blanks for us. You fill in the blanks about OAuth, about both authorization and authentication, which we very much appreciated. But in this case, we've got a question for you for the sentence of AppSec is most likely to what? How would you complete that sentence?
AppSec is most likely to keep changing. I don't think it's ever going to be a fixed thing, and you're always going to have to keep learning new things and keep adapting.
It seems like quite a fair response, and we'll cross our fingers that you can at least get the 2.1 spec out before AppSec changes too much. But thank you very much, Aaron. I really enjoyed this conversation.
Yeah, thanks so much.
Thank you, Aaron. Thank you as well to John, and thank you to everyone listening. We're going to take a quick break now and return with news of the week.